System by system can be viewed as interconnection of operation. Okay, so remember that half wave rectifier input was a neat looking sinusoid. Your output in case of half wave rectifier was something like this, right? So you can see half the waveform retained, right? I am yeah, half of the waveform chopped off. So it was like input DC AC was converted to output DC with AC component whose frequency was same. Whereas when you gave it to a full wave rectifier, it converted into something like this, right? Okay, something like this. It's an AC with frequency that is doubled from the input. Whereas if at all I give it to an amplifier, what it is going to do, it's going to convert it into a sinusoid with a very large amplitude, but a phase shift of what, how many, 180 degrees, how many degrees, -1, right? What this particular thing, that's what a system does. So output, whatever you're getting, will be having different properties than that for the input. Okay, that's a system. Usually input is represented by x of t or x of n. Output is represented by y of t or y of n. And the action of the system is represented by nh. So whenever we write an h and then we write bracket x of t, that means this particular system h acts upon the input x of t to give you output y of t. Okay. So in what sort of way, what all things can we do? What all things is a system capable of doing? You can see interconnection of operations. What sort of operations? Let us see. Let us see the operations here. So there are two ways of doing this thing. Okay. Two ways of doing this. You can see what sort of operations we are talking about. There is a shift operation. Okay. Shift operation means the shift operator, what does it do? You give input of x of n. You can see after shift, it has become x of n minus 1. There is also called as something called as integration operator, where if at all you do this one integration like this, input is x of t, the output is going to be integral, one integration of x of t, integration of x of t, I would say. Okay. There is a integration operation. There is a shift operation. Okay. There is a shift operation. X square, if at all I say, this means x of n minus 2. N minus 2. Simply s is there. Then it is x of n minus 1. Okay. So if at all I say, then the signals can be added. There is summation operator. Signal can be added. If at all I put a plus mark here, and say for the third one, say I put a minus mark. This means x of n plus x of n minus 1 plus x of n minus, minus x of n minus 2. Okay. So there can be shifts, there can be integrations, there can be summations, there can be multiplications or divisions. Okay, there can be multiplications or divisions. Usually they simply put a line and put a arrow. Okay, where they write a constant here, 1/3. This means the whatever signal that is there in this particular side is being divided by 1/3. Okay, got this particular thing? This is how. So this here is an example of a moving average system. Where is that? Here you can see. So see, this is a moving average system. Okay. So this is a moving average system. How much marks did you score in your current semester or a current year? Say final year student, if at all you're asking, what is your third year student maybe who is in sixth semester? What is your current CGPA? Then how will it tell? Marks in the fifth, marks in the fourth, marks in the third, marks in the second, marks in the first semester, right? Something like that. If at all you ask a student in who has come to say final year, okay, who is yet waiting for a result, what is your CGPA till now? He would say marks from third year plus marks from second year plus marks from first year divided by 3. Okay, such a system is called as a moving average system. This system, current value plus previous value plus value previous to that, all those divided by 3. Okay, are you convinced? Now say we want to implement this particular thing. Okay, say we want to implement this particular, so what does the system do, by the way? Here, can anybody tell me this particular system, what does it do? Can anybody tell me what does the system do? Will somebody tell me what does the system do? If at all
Finding the average.
it takes in the moving average. Okay, this system is called as taking moving average. If at all you are seeing cricket matches, right? Nowadays it's all T20, usually it's ODI. They would show the current form of a batsman. A current form of a batsman is shown by how much he has scored in last 5 innings or how much he has scored, right? Say it is Virat Kohli or this some newcomer. Okay, some right, some newcomer, doesn't matter. He has played 100 matches or 300 matches, but then the current form is decided by how much he has scored in last 5 innings. So when they do that, what they will ask? They ask current match, match previous to that, and then okay, they take a average. So such thing is called as a moving average system. Okay, so now we say if at all I give input as x of n, the system returns you y of n will be moving average. So what does the system do? System determines the moving average. Okay, that's what they say. So the h, describe h. What does h do? Moving average. So here this is a symbolic representation. What actually happens is described by this particular equation. Now how can we do this particular thing? See, we need addition here, we need summation, sorry, we need division also, collective one based on all these 3 operators, and we need to introduce the shifts. Previous value, what shall we use? D flip-flops. Remember, D flip-flops, one D flip-flop can store one previous value. So that S in the box, it actually indicates the D flip-flop. Okay, so here it is. So here you can see the symbolic representation is S to the power k. If k equal to 1, this is x of n becomes x of n minus 1. K equal to 2, x of n becomes x of n minus 2. Sometimes they also represent it as z to the power minus 1. Let us not get confused for the time being. Let us use this representation only. Okay, so how can we do this particular thing? Author says there are 2 means. One is called as a cascade form and another one is called as parallel form. Okay, what is this cascade and what is this parallel? Okay, what is this cascade and what is this parallel? Let us see. Now here you can see 2 approaches. In first approach, your input first goes here. Okay, you can see at this particular instant, my data is not ready. Data has to go here. After time instant 1, there is some junk data here. Data after time instant t1, now you have valid data. Okay, at time instant t0, there is in input only at x of n. This data missing, this data also missing. After time instant, say t1, after 1 second or 1 match or 1 day, whatever it is, then you have 2 valid data. Data here, data here. Here there is some junk data. After time instant t2, now you have the data ready. Okay, here also, here also, here also. So this particular type of implementation, then you accumulate all the data. You accumulate all the data. Finally, you divide it by say 1/3. You get your output. This is one approach. In the second approach, what you do? Simultaneously, your x of n, x of n minus 1 and x of n minus 2, all of them are fed simultaneously, and then you are dividing it. This particular approach, of course, the example by the way is not so convincing, but let us buy this. Okay, let us simply buy the argument. This first approach is called as a cascade implementation, things connected back to back. Okay, whereas this second approach, as the diagram indicates is called the parallel form implementation. Okay, so every now and then you will be encountering this. For any kind of system implementation, you can go for either cascade implementation or parallel implementation. They say cascade implementation might be slow due to the delay in getting all the data. Parallel implementation might be faster but might come at a cost of additional hardware. Okay, you can see S and an S square. S means 1D flip-flop, S square means 2D flip-flop here. Rather here we had to wait 1 second extra. Okay, 2 second extra, but then we can manage with lesser resources. Okay, so I know you are confused, but let's not get confused much. Let's just move on. Okay, let us just move on. So that was about a system. So what are the properties of a system? Systems can be stable or unstable. Systems can be with memory or they can be memoryless. Systems can be causal or they can be non-causal. Systems can be invertible or non-invertible. Systems can be linear or non-linear. Systems can be time variant or time invariant. Okay, so what are the properties of systems, by the way? Let me tell you once again. So systems can be stable. So just as we discussed about the signal, right? What are the classifications of signal? Signals can be continuous, signals can be discrete, signals can be even, signals can be odd, signals can be periodic, signals can be aperiodic, right? Something like that. Similarly here, see, so stable systems can be stable, systems can be unstable, systems can be memoryless or systems can be with memory, systems can be linear or they can be non-linear, and then there are two more: systems can be invertible or non-invertible. Okay, okay, these words are somewhat, let us see them one by one. Once you know what those are, then it will be easier for us to remember. Let us start with stability. Systems can be stable or systems can be unstable. What does this mean, by the way? What does this stability mean? A system is said to be both stable, bounded input stable, if and only if every bounded input results in a bounded output. Oh, what does that mean? What does that mean? Now say, let me take a system y of t equal to t into x of t. Y of t equal to t into x of t. Okay. What this means is, let me describe this by, say x of t is what shall I call, price of 1 kg of rice. Okay, say x of t is price of 1 kg of rice. Okay, so what's going to happen is, as and when the time changes, the price of rice goes on changing. Okay, price of rice goes on changing. So what do you think? Is this a stable system or an unstable system?
Unstable.
Huh? See, right? See, as and when the time changes, does t wait for anything? No, right? Time goes on increasing. So because of which the price of rice also goes on increasing. Price of this is a constant, but because of t, this goes on increasing. Whereas if at all I say, if at all a person, what should I say? The requirement here is your input should be stable. Okay, your input should be stable. For stable input, you should get a stable output only. Let me take back you to that previous example here. This example. Okay, now you can see. So here in this particular case, if at all your inputs are stable in the sense some value less than infinity, then is there any means by which this y of n can go to infinity? No, right? For any stable values, 3 stable values, their addition will also give you stable value only, and the result, whatever you are going to get, will also be stable. If at all you add 3 values and divide by 3, then you are going to get a stable value only, right? So this I will say is a stable system. Whereas if at all I add one more, see out of this what I will do is instead of this particular term, say if at all I add an n here, if at all I add a n here, then what's going to happen? Then as and when time increases, as and when time goes to infinity, this y of n, even though your x of n is stable, because of this n term here, as and when n goes to infinity, n divided by 3 is still infinity, right? So that is when this entire system goes unstable. Okay, this entire system goes unstable. Okay, got this particular thing. So even for those systems for which even for stable input, if at all your output goes infinity, then they are called as unstable system. Okay, the condition you can see for all t. Okay, so let me take one more example to convince you. Something like y of n equal to x of n, x of n plus 2. Now tell me, this particular system, what do you think? Stable or unstable? What do you think? What does your common sense say? What does the system do? Takes in the input, simply adds 2 to it. What do you think? Is the system stable or unstable?
Stable.
Hmm?
Stable.
It's a stable system, right? So for all t, okay. Now say, okay. Now y of t equal to x of t plus t. X of t plus t. Now what do you think? Somebody tell me.
Unstable.
This is unstable because see there is a t here, right? There is a t here which at t equal to infinity. Okay, you have this stone, a 1 kg stone in the grocery shop. It is stable because even after 100 years, the stone will weigh 1 kg only, right? So that is stable. Okay. Whereas if at all I have something like this small tree planted in my house, and say my house is full of those duration sheets, that tree keeps on growing. Okay, in front of home I am a big what do you say, nature lover, but the tree after 15-20 years is going to grow very large. So after 50 years what's going to happen? Me or my kids, I don't know. Okay, but the tree may fall, right? It's a unstable system. It is going to grow bigger. Whereas a banana plant that you have planted, what do you think? A banana plant stable or unstable? A mango tree planted, not those one which you see in Bhatka, okay, cute looking ones. You should say a comment, see those in the forests. They grow very big. Whereas a banana plant that you have planted, that is stable. It doesn't grow above some 15 feet and it disintegrates on its own. Okay. That's about stability. Okay. Of course, we will take some examples also. Okay. I just thought of, convincing you. Okay. See here, as per author, this moving average system is absolutely fine. The requirement, you can see, this is the requirement. Input should be stable. Okay, if at all you give some stupid inputs which are not stable, you cannot expect your output to be stable also. Okay, moving average system is cool, that is stable. Here is one more interesting example. R to the power n into x of n. Okay, r to the power n into x of n. So shall we take this example? Say r is equal to say something like, okay, let me take you to the whiteboard now. Y of n equal to r to the power n into x of n. What do you think, by the way? Stable or unstable? Y of n equal to,
Unstable.
let us see. Y of n equal to, let me draw 3 of them. R to the power n into x of n. Okay, r to the power n into x of n. Then second one I will write y of n equal to r to the power n into x of n. Then let me multiply this by u of n. What is the meaning of u of n? Whenever I multiply anything with u of n, that means I will take only the values on the right side. See here, this x of n, I have not multiplied this with u of n. That means it will, n will be there from minus infinity to plus infinity. But whenever I multiply anything with u of n, that means now I start considering values only from 0 to infinity. Okay. Okay, cool. Now let us start. Okay. Let us say x of n equal to 1. Okay. Let us say x of n equal to stable. How stable things can be other than 1? 1 is cool, right? 1 is stable. Let us say x of n is equal to 1. Then say for r is equal to 0.5. What's going to happen? For r is equal to 0.5, what's going to happen? What did I ask you? Assume that x of n is equal to 1 because it is stable, right? Even though x of n is equal to 1, r to the power n, what's going to happen at n equal to 0? What will be r to the power n? At n equal to 0, r to the power n? 1.
1.
N equal to 1, 0.5, 0.25, 0.125, and so and so. It goes on decaying, right? It goes on decaying. But then what's going to happen on the left side? R to the power point of -1, R to the power -1 is what?
Increasing.
It is increasing on the left side, decreasing on the right side, increasing on the left side. So is it stable, by the way? No. Okay, this
No.
is not stable. For R less than 1 also it is not stable. R greater than 1 also this is not stable. Okay, magnitude R less than 1 also it is not stable. Greater than 1 also it is not stable. What about this one, by the way? Now what I have done is I have multiplied this with u of n. When you multiply this with u of n, you know what's going to happen? I need to consider values only on the right side. Now I can once again start. Now if at all I take magnitude R less than 1, say 0.5. Now this is cool. Now this is going to be decaying on the right side only. Is it existing on the left side, by the way? No, no, no. It's not going to be there on the left side because I have multiplied this with u of n. So now I would say this particular second signal, this one is anyway unstable. This system is unstable, even though you give stable input. This second one, by the way, is stable for r less than 1. For magnitude r greater than 1, this is also unstable. For r greater than 1, what's going to happen? For r greater than 1, this is going to go like this. Okay, this is going to go like this. So that was the first example called as stability. Okay, that was the first one called as stability. What about y of t equal to e to the power x of t? What do you think? E to the power x of t. This is a confusing one, I guess. Okay. Let us leave it at that. Okay. We'll discuss more. Now, the next one. Now, yeah. So that was the first one, stability. Okay. Now the second classification, by the way. Second classification is memory. Okay. A system is said to process memory if its output signal depends on past or future values. If at all the output depends only on the present value, then the system is memoryless. Now see here, for this particular case, is output y of n decided on the previous values of x of n? No, no, it depends only on x of n only, right? Now let me take this previous example. What was that? See here. Now here x of n, y of n depends on x of n current value, n minus 1 and n minus 2. Your current semester, previous and previous to that. Okay, so it is referring to previous values. So since this y of n depends not only on x of n but x of n minus 1 and n minus 2, this is called as a system with memory. Okay, this is called a system with memory. If at all I take y of n equal to x of n plus x of n minus 1 minus 1 plus x of n plus 1 plus x of n plus 1, then what's going to happen? Then also you say it is a system with memory. In this particular case, say y of n equal to x of n plus x of n minus 1 plus of x of n plus 1. Now listen to me carefully, everyone. This is Virat Kohli score in the current match. previous match previous to that. Okay, are you convinced? Your score in current semester, previous semester previous to that. What about x of n plus 1? Then what is x of n plus 1? Can anybody tell me what is x of n plus 1 in the same analogy? If this is the current,
The next semester.
okay, next semester, right? So when I say x of n plus 1, I am referring to future values. N minus 1, n minus 2 are past values. N plus 1 is a future value. Whatever it is, it's not the current value, right? So that is why such systems are called as systems with memory. Okay, those systems are called the systems with memory. Okay, those systems are called the systems with memory. Let us see what example author has to give. Moving average. Okay, you remember when we were studying LCR circuits and all, they said a typical resistance is the only memoryless thing. Inductor and capacitors, they usually indicate those devices with memory. Okay, you remember this order of a system. Do you remember what are first order equations, what are second order equations, by the way?
Yes, sir.
The order, you can see, if at all a circuit contains a resistance and a capacitor, it will give you, fetch you a first order equation or second order equation. If at all there is a LCR circuit, say there is a circuit with a resistance and a capacitance. If at all you apply,
First order.
it's going to give you first order. If at all I have a circuit with a resistance and an inductance, then does it yield you first order or second order? Resistance and an inductance. In case of
So if
capacitor,
we differentiate it, then we are going to get
first order only. Okay, either you are going
first
to
order.
term and an
First
integral,
order only.
or you will have a term and a differentiation, right? Whereas for an LCR circuit contains a resistance, a capacitance, and also an inductance. And you can see an LCR circuit usually give you a second order differential equation. So that order actually indicated the number of memory elements. Which are the memory elements? Capacitor and inductors. So usually whenever you see a circuit, a continuous time circuit containing an inductor or a capacitor, it usually they indicate systems with memory. Okay. For discrete time, whenever you refer to x of n minus 1, n minus 2, x of n plus 3, they are systems with memory. Okay. You can see here this particular system, since it doesn't, it refers only current value, squares it, but refers to only current value. It is called as a memoryless system. R to the power n into x of n, whatever you did earlier, that also is a memoryless system. Okay. Now, do you remember this example as I told? If at all I put a plus 2 here, current semester marks, previous semester marks, and marks you are going to score in, say, if at all I write x of n plus 1, future. Okay. If at all you have a system which is going to refer to future values, if it refers to future values, then we say such systems are called as non-causal. Can you predict, by the way, how much marks you can going to score? You are going to score in the future semesters? Exactly. No, we always want to score good, but can you predict? No, it's nonsense. Okay. So such one, it actually happens in notebooks and textbooks, right? But in real world, such thing never occur. That is why those systems where if at all you are referring to a future value, it output depends one or more future values, then they are called as non-causal systems. Whereas if at all you refer to current value or previous values, this is fine. If at all you refer to current value or previous value, then they are called as causal. This is perfectly fine. Causal, cause, right? What caused the issue? Cause means something that happened currently or previously, whereas non-causal is the one where you are referring to future values. The moment you see x of n plus 1 or x of n plus 2, it is straight away non-causal. Okay, I think your next class is scheduled now. Everybody just type in a hi. Everybody just type in a hi. Let me, tomorrow what we'll do, we'll consider the other two very interesting ones, linearity and time invariance. Okay, very interesting, little tricky also. Okay, we will do that tomorrow. Okay, so did everybody type that hi thing? So you have, right, your next class scheduled, or you are free?
Sir, we have next class.
Okay, okay, huh? Let me end this.
12 I will be
Sorry
taking.
for the thing. Okay, there was some glitch. Okay.